Good afternoon. I'm Mohan Kumar. I'm with Intel. I'm a fellow there. I'm going to talk to you today about Redfish and immersion cooling management. And so the reason for this is that there is. So let me just flash the agenda, and then we'll talk about it. I'm going to talk to you about what it takes to do immersion cooling management and some of the intricacies that come with having the redundancy and some of the markup. So it's a technically oriented discussion and how we handle the sensors that are in there, and I'll conclude and finish there. And the first step is that why are we even doing this, right? One of the things is that as Redfish is a DMTF specification, and as you move from as you move some of the cooling and power equipment that used to be more in the data center side of the house into the IT side through things like immersion cooling or cold plate or rear door heat exchangers, then you need to look at how do you comprehensively manage the whole thing, right? So just having the server and storage be Redfish, Swordfish, whatever it is, but how do you manage the rest of the equipment that comes along? And until recently, there was not a good answer for that. So one of the things that, at least the work that we have done, along with Jeff Order sitting over there, is to essentially take the thermal equipment model and extend it to cover all the emerging solutions that are at least coming up in the thermal space. So let me quickly give you a quick overview of immersion cooling. Essentially, if you think of immersion, there are varieties of immersion cooling. I'm kind of showing the one that's hardest to solve from a manageability standpoint. Everything else is relatively easier from this standpoint because this has the most touch points in the way manageability looks at it. So instead of these servers being in a rack, they're going to be inside some kind of a tank with some coolant. And that coolant has to be, in this case, which is a single phase, the coolant has to be actively pumped by a coolant distribution unit. And then that heat that's taken away from the tank has then rejected to a facility loop, where that facility loop is typically a water loop, right? There are other implementations, but for today's discussion, this is probably good enough. And the CDU, the coolant distribution unit that's shown in the middle on the picture, it could be co-located inside the tank, or it could be outside the tank. There could be, one of them, multiple of them. There could be multiple tanks for one of them, which I'll show later. So there's lots of variance in this space. So usually there is like a PLC logic that's controlling all the sensors that are inside, and you're able to measure the sensor. And if you're going to manage this, you want to know all those details and be able to expose them through some standard interface, so everything is not proprietary and completely invisible to the platform. And if you were in some of the previous sessions that talked about PFAS and two-phase solutions, two-phase will be a little bit easier than that because there will be no CDU. It will just be a condenser, and then you go straight into the facility loop in there. The facility loop typically is multiple stages. I oversimplified the picture just to make it easier because sometimes multiple stages in the data center as it goes out. But from a manageability standpoint, again, it doesn't matter, right? So now let's look at the tank and the CDU, which is the part that we want to model. Facilities, technically we could model, but we don't really dwell on it because there's a lot of stuff. There is a DSIM that takes care of it in general. There is typically you could have a manager, right? A management controller, then that could sit within the CDU or outside the CDU. It depends on the implementation, but invariably this coolant distribution unit has got a PLC, right, programmable logic controller, and then all the sensors and actuators that are inside the hardware of the cooling is all tied to these things, right? So what is your cooling capacity currently? How are they connected together? What is your telemetry telling you right now on how things? What's the flow rate? What's the temperature in? What's the temperature out? What failures are happening? All this data is being collected and done through this, typically through a PLC, right? Again, oversimplified picture with a single PLC. Implementation details may vary. But typically, this is like a Modbus type interface inside of these systems because these are all controller type systems. But what we want is to have something that exposes a standard interface on top of this. And how do we get there, right? That's the question that we want to ask. So before we get to that, we want to look at what's out there that we can use. And Redfish did an excellent job. Jeff, I believe you wrote that spec, right? For thermal equipment model that allows you to model various of these cooling technologies emerging, right? On the, I can see very well from here. So, so on the left of the picture is a cold plate type solution, and on the right side of the picture is a rear door heat exchanger. As you can see, at a manageability modeling level, they're very similar, right? So to us, you're modeling a coolant distribution unit, you have a primary loop, and you have a secondary loop, and essentially you're connecting up the loops and managing it, right? So whether it's direct to chip or rear door, it's all modeled very well, and the 3D. They will take to this the documentation and the DMTF website if you want to look it up for further details. And what it looks like at a modeling level is that, so Redfish typically starts with the service route, and usually you go to chassis and servers and so on. Now instead we go to a different new category called thermal equipment, and then the cooling loops and the cooling distribution units, everything sits under there, right? So essentially there are a bunch of collections. So just like rack is part of the chassis, right now the tank will be part of the chassis, and then there is a cooling unit collection, which is what Redfish calls it, and then underneath that you have the typical coolant distribution units that sit there. And then inside the CDUs, there are pumps, and then there is a pump collection, because you could have more than one, right? This is one of the interesting parts of redundancy, is that you don't want to take something, collect a bunch of servers, put it all into a tank, and then put it at the mercy of a CDU that can fail and have a single point of failure. So typically folks have either redundancy in terms of CDU or redundancy inside the CDU in terms of pumps. And we have the ability to model both those options using this solution. Okay, so what the work we had to do was to essentially extend this model to also cover immersion cooling. So that meant that two things had to be done. One is the redundancy model, which I'll go into, and the second thing was sensors. As I've shown you before, right, the sensors sit in a place that's not the same as actually where they come out of. Because one of the interesting portions of Redfish is that it stops at where somebody is actually able to talk Redfish at that level. These microcontrollers underneath, they are all talking. Like in this case, most of the cooling and heating equipment tend to talk, Modbus, right? So we can model them because we don't see them at the Redfish level. So you don't know who is connected to who. You believe, so whoever is showing up as connected is what you see. The actual physical connection is somewhat transparent to you, but it's relevant if you're going to send a service call based on the manageability interface. So being able to model it accurately is a key thing to do, and those are the problem we had to solve. So now first let me get into redundancy. I know it's a little bit of a busy slide. So you could have the simplest implementation where you have like a facility cooling loop, you have one CDU, and you have a tank, right? Easy. It's a 1:1 mapping between the CDU and the tank. So like I said, the CDU might have single pump, or typically they have multiple pumps because they don't want to have a single point of failure. But they could also have solutions where you could have a single CDU supporting multiple tanks. Or if you want redundancy, you could have multiple CDUs supporting a single tank, right? Because I don't want anything here, like in the very bottom, the 1:2 that I'm showing. That's what I want to do when I'm going to take a mission-critical piece of equipment and I'm going to cool it through some liquid cooling mechanism, because I don't want anything, including my water loop failing, to be a point of failure. So they want to have two water loops, which means I have no choice but to put two CDUs in the path, right? So, I mean, granted, it's more complex and more expensive, but if you want mission-critical, that's what you go to. And so these are the things, all of these topologies. And again, I'm just showing a sampling here. It could go up to n, depending on what's your comfort level and what kind of tolerance you want to have for failure, right? So all of this need to be modeled in the solution, and I'll show you that we have modeled that. And at this point, I want to acknowledge John Bean. I don't know if he's here from GRC. I've sent multiple configurations to him saying, can you really do this configuration? And he's been very patient in answering my questions. So this is a translation from the 1:2, right? One CDU supporting 2-tank model. So what you do is to have the tank collection basically have to the 2 tanks represented, and then the thermal equipment essentially points to the cooling unit collection with 1 CDU, as you can see, and the 1 CDU has got 2 cooling loops, one coming in and one that's taking the heat away from the immersion tank to the water loop outside. And then the primary water loop we typically don't model. We could, but it's not necessary because now we are kind of drifting into a space that doesn't quite belong to IT. It's really a data center space. So that's the model. So as you can see, I'm going to make my case that Redfish can solve these problems, and actually we have built this at Intel on an immersion tank, and we know it works. So just to point at a few things, right? So first thing was to introduce the property of redundancy. So Redfish had the concept of redundancy for power because power supplies have been redundant forever in the server world. So we had to just borrow the same concepts and bring them into essentially solve that. I know I'll show you a pointer there later if you want to go look up. This code is published, I believe, through a web in Redfish, so you can look at it. I'm just showing you, right? So here, I'll just, I know it's an eye chart, especially with that color, but essentially what it's showing is that there are two cooling distribution units, and they are redundant with each other. One of them could fail, and the other one will take over, right? And you're essentially describing this redundancy through the Redfish model. So you can look at the model, and you know that you don't have to worry about the redundancy is built in, and there's going to be a failover in case one fails, and you can go to the next one automatically, right? All of this description is well built into the model, and this is some of the work that we did with the Redfish forum to get us there. And the second thing is the sensor management. This was really fun because this is where if you had physical access to the tank, you see that the sensors are sitting in the tank. But if you only are looking at it through software, you would see that the sensors are attached to the coolant distribution unit. You don't see the fact that the wires are actually going into the tank. You don't see it at all, right? So now, how do I tell? So this means that I need to have models for what's physical, okay? What's physical and what synthesized sensors in the model. So we solve this problem by essentially using a few things, right? Essentially what this is showing you is that we said that physically, where does this thing show up? It shows wherever the PLC is, and the PLC is in the CDU, and the PLC, this example in the slide is saying that it's in the PLC. But I needed to know if there is ever an event, I needed to know where to go, where to send my service representative, right? So we created this, the highlighted portion shows you a related item, and that essentially points to the immersion tank, and it says the immersion tank 1 is the one where the sensor is attached to, so you want to go to the immersion tank 1. So we solved the location problem through that mechanism, and we are working on better ways to improve it in the future, but for now, this works. At least we know we don't have to send you to the wrong place, right? We don't send you to the CDU when it's actually at the tank level. Second, we have to have, so Redfish has another concept called sensor excerpts, right? So you can have the sensor one place and then the excerpt of the sensor sitting in another place for you. So we use that mechanism to solve this problem of, PLC is going to surface the sensor, but I need to tell you how do I tell the tank has got a sensor? So we use the except mechanism to basically show that here is the tank's value for the temperature right now. And so we reverse it inside to essentially produce the values that you would expect to see normally, right? Because you physically look at the tank, the sensor is there. Logically, it should look the same, right? The fact that your manageability wiring is different doesn't matter to some user person, so you have to make it look. So essentially what we are doing is reversing that tangling that was done by the manageability layer to show it to you the right way in this case. And with that, essentially, the Redfish thermal model now can support every possibility, right? Any liquid cooling, the direct-to-chip, immersion. I know there are folks that are doing hybrids, and all the. I know I focused on single phase because that's a harder problem from a manageability standpoint. Two phase also works. It's a little bit easier from a manageability standpoint. And these extensions have been submitted to the Redfish forum at this point from OCP, and thank you for accepting it. The goal was to essentially get to a place where we have a converged management of IT and cooling equipment, given that they are inside our domain now, right? They are no longer in the data center domain, they are inside the IT domain. So with that, I want to leave you with the call to action. So here is the link to the Redfish thermal equipment model. Please adopt it if you're going to look at solutions in this space. And work with us if you have any specific solutions or problems that you want to solve here. And we're also working on a white paper. It's not quite ready, but we will publish it soon that talks to the model in greater detail. With that, I thank you for coming here. And if you have any questions, I'm happy to stay back and answer them.